First of all, we need to find the gradient of this line. So we have to rearrange. So 2x minus 6, taking the minus 3y over gives us 3y. We then divide all through by 3. This gives us 2/3 x minus 2 is equal to y. We could write this round the other way. Y equals 2/3 x minus 2. Gradient of this line is 2/3, and we know if two lines are perpendicular, m1, m2 is equal to -1. So the gradient of the line perpendicular to this will be -3/2. So the answer is A. un plus 1 equals 2un plus 3, so we can write that u1 is equal to 2u0 plus 3, and we can write that u2 is 2u1 plus 3. So first of all, to find u1, 2 times u0 plus 3, u0 is 1, 2 times 1 is 2, plus 3 is 5. We now use this second equation to find u2. 2 times u1, which is 2 times 5, plus 3, which is 13. So the answer is C. 3 times u is 3 times this vector here, which with 3 times 2 is 6, 3 times 0 is 0, 3 times 1 is 3. We want to take away from this 2 times the vector v. Now 2 times the vector v is 2 times -1 is -2, 2 times 2 is 4, 2 times 4 is 8. Taking them away gives us the vector 6 minus -2, which is 8, 0 minus 4, minus 4, and 3 minus 8, which is -5. So our answer is B. Maximum minimum value is 2, the minimum is -2. This tells us that A is 2. Now if we look at the period, this graph is repeated once, twice, 3 times in the space of 2 pi, and this tells us that the value of B must be 3. So the graph we're looking for is y equals 2 cos 3x, so the answer is A. X squared plus 8x plus 3 we want to put into this form. So we've got x squared plus 8x. If we take half the coefficient of the x term, it gives us 4. If we now square that, we get 16. If we now insert plus 16 minus 16 in at this stage, the plus 16 combines with the x squared plus 8x to give us our square, which is x plus 4 all squared. The minus 16 plus the 3 gives minus 13. We're asked to find the value of q, so it's minus 13, so the answer is B. The roots of the equation are equal, and the condition is that b squared minus 4ac would be equal to 0 for that. But first of all, we need to write down the values of a, b and c from the quadratic. Value of a is what's multiplying the x squared, so that's k. Value of b is -3, and the value of c will be +2. So we now work out b squared minus 4ac, and because the roots are equal, we know that this must equal 0. B squared is -3 squared, which is 9, minus 4 times k times 2, so that will be minus 8k equals 0. Rearrange this, we'll get that 8k is equal to 9, dividing by 8 gives us that k is equal to 9 over 8. So the answer to this will be 3. To find the limit of a recurrence relation, if we let the un plus 1 equal L, and also let the un equal L, then L will be equal to 1/4 L plus 7. If we minus 1/4 L from each side of this, that's the equation. 1L minus 1/4 L is 3/4 L. The 1/4 L cancels with minus 1/4 L, and we're just left with 7 on the right hand side. We want L from this. Now one way of doing this would be to multiply both sides of the equation by 4/3. By multiplying 4/3 times 3/4, these numbers all cancel and they're just left with L is equal to 7 times 4 is 28/3. So the answer to this is part C. From the equation of the circle, we can work out the centre. We take the minus 6, we half it and change the sign, so that's 3. We take the minus 10, half it and change the sign, gives us 5. So the centre of this circle is the point 3, 5. Now the y-coordinate 5 means that we go up 5 from the x-axis to get to the centre. So in order to get up to this point, we'll have to go up another 5. So the y-coordinate of this point is 10, its x-coordinate is 3, but we're asked the equation of the line L, so the equation of the line L is y is equal to 10. So the answer to this is B. The integral. To find the integral of this, we add 1 to the power, 2x to the minus 4, so that becomes 2x to the minus 3, and we divide by that new power. Then integrating cos 5x gives us 1/5 sine 5x, and we can see that from our formula sheet, plus c. Now the 2 over the negative 3 is negative 2/3, so we're looking for the answer negative 2/3 x to the minus 3 plus 1/5 sine 5x plus c, so our answer to this is answer C. If two vectors are perpendicular, then they dot to give 0. The two vectors in this case, x, 5, 7. Now we want to dot this with the vector minus 3, 2, minus 1. Now to dot two vectors, we multiply the two x components. X times minus 3 is minus 3x. 5 times 2 plus 10. 7 times minus 1 is minus 7. Now we know the answer to this is 0 because the two vectors are perpendicular. If we rearrange this, 10 minus 7 is 3, minus 3x over to the other side becomes plus 3x, and dividing each side by 3 we get that the answer that x will have to be 1, so the answer to this is B. F of g of pi by 6, we'll work out g of pi by 6 first of all. Now g of pi by 6 will be pi by 6 plus pi by 6. Now pi by 6 plus pi by 6 is 2 pi by 6. We can cancel off the 2 with the 6 to give pi by 3. So that's g of pi by 6. We now want to apply f to this. So it's f of g of pi by 6. So that's f of pi by 3. F of pi by 3 is cos of pi by 3. And cos pi by 3 is an exact value, which is the same as cos 60, which is a half. So So the answer is D. Before we can differentiate f of x, we have to change the form of this. So f of x is equal to 1 over, now the fifth root of x is x to the power 1/5. Still can't differentiate, but we can take this up to the top. When we take it up to the top, it becomes x to the power negative 1/5. Now we can differentiate. F dashed x multiply by the power that's there already, which is negative 1/5, times x to the power negative 1/5 minus 1. Now minus 1 we can write as minus 5/5. Minus 1/5 minus 5/5 is minus 6/5. So this is the answer A. Now in the quadratic, if A is greater than 0, that tells us that we've got a U-shaped parabola, which means the parts C and D are ruled out straight away. B squared minus 4ac greater than 0 means that we've got two separate roots. Part A has only got one root, part B has got two distinct roots, so part B is the answer. Shaded area is the area between two curves. That integral will be represented by the integral from -2 to +2, which is the two limits, of the upper equation for y minus the lower equation for y. So this is the integral from -2 to +2. Now the upper equation for y, this curve, is 14 minus x squared. The lower equation for y is y equals 2x squared plus 2. So 2x squared plus 2 goes in here. Now when we take them away, take the brackets away, we have got 14 minus 2, which is 12, and minus x squared minus 2x squared, which is minus 3x squared. And we see that this is answer C. To find if f is increasing at x equals 1, we fit x equals 1 into the f dashed x formula. F dashed of 1 is 1 squared minus 9, which is negative 8. This is less than 0. So this means that f is actually decreasing at x equals 1. This first statement is not true. If f is stationary at x equals negative 3, then when we work out f dashed of negative 3, we should get the answer 0. F dashed of negative 3, fitting in negative 3 for x, is negative 3 squared minus 9, which is 9 minus 9. This time we get the answer 0, which means that f is stationary at x equals 3. So only statement 2 is correct. The answer is C. To find out where this graph crosses the x-axis, we would make this equal to 0. This then gives us that x would equal 1 twice, and also x would equal negative t. Now looking at the graph, we see the value of 1 twice, equal roots, and the other value is 5. So x is equal to negative t, which is equal to 5, but this means that t is actually negative 5. Now, to find the value of k, we know that the point 0, 10 is on the curve. So when we fit in x equals 0 into this formula, we should get the answer 10. So y is equal to k, fitting in 0, 0 minus 1 squared, times 0 minus 5, and the answer to this is 10. Minus 1 squared is 1, times minus 5, this is minus 5k, equals 10. Dividing by minus 5 tells us that k is negative 2. So k is negative 2 and t is negative 5, and this is answer A. The rate of change of s with respect to t is the derivative s dash t. So differentiating s of t, t squared differentiated is 2t, minus 5t differentiated is minus 5, differentiating plus 8 is 0. We want the rate of change when t equals 3, so we need to now work out s dashed of 3, fitting in 3 into the formula for s dashed of t. So it's 2 times 3 minus 5 to 6 minus 5, which is 1. So the answer is B. To solve this inequality, we first of all solve the equation x squared plus 4x is equal to 0. Factorising x bracket x plus 4 equals 0. This gives us that x equals 0, or x plus 4 equals 0, or x is equal to minus 4. This is the solution of the equation. X squared plus 4x is a U-shaped parabola, and we've just worked out where it crosses the x-axis at negative 4 and at 0. We want to know where x squared plus 4x is greater than 0 or positive. And that will correspond to this part of the graph and this part of the graph. This part of the graph corresponds to values of x that are greater than 0, and this part corresponds to x is less than negative 4. So the answer is B. This is a logarithmic function that's been shifted to the right from its normal position. If we imagine it moving back, the normal position, it would pass through the point 1, 0. Which means we have to move it back 3. This point would also be moved back 3 to the point 3, 1. When we see that, we see that the original graph must have been log to the base 3. And because it's then been moved 3 to the right, in the brackets with the x will go minus 3. So this is the graph log to the base 3 of x minus 3. So the answer is C. To get to this position, the graph of y equals f of x has undergone 2 transformations. What we'll do is undo each one in turn. First of all, f of 2x minus 3. The minus 3 means that the original graph was moved down 3. So to undo this, I'll move this graph up 3. This will take the turning point to the point 6, 7. So we've undone this part. Now f of 2x, from the original graph, to get from f of 2x to f of x, because the 2 is multiplying the x in the brackets, the original x coordinates in the graph will all have been divided by 2. So this point 6, 7 will have come from the point 12, 7. And this will have been the turning point on the original graph y equals f of x. So our answer is A. Find the equation of the median BQ. We first of all need to find the gradient of BQ, but before that we need to find the coordinates of Q. Now Q is the midpoint of AC, so we can use the midpoint formula using the points A and C. So to work out the coordinates of Q, we take half the sum of x1 plus x2, which is 4 plus 18 is 22, half of that is 11. y1 plus y2 is 20, half of 20 is 10. If we now take the point B, which is negative 4, 16, we can work out the gradient of BQ by using the gradient formula. y2 minus y1 over x2 minus x1. So that's 16 minus 10 divided by minus 4 minus 11. So that's 6 over negative 15. We can cancel this down by dividing by 3, and that will give us negative 2/5. Now, in order to find the equation of BQ, we need point and gradient. We've just worked out the gradient is minus 2/5. We can use the point B or the point Q. Now the point B is negative 4, 16. To find the equation, we fit these values into y minus b equals m bracket x minus a, where AB is the point. So this is y minus 16 is equal to minus 2/5 bracket x minus minus 4, which is plus 4. We could multiply across by the 5 here to give 5y minus 80 is equal to negative 2 bracket x plus 4. Multiplying out these brackets, 5y minus 80 is equal to negative 2x minus 8. And we can rearrange this to give 5y plus 2x is equal to plus 80 minus 8, which is 72. And this is the equation of BQ. Now, to verify that T 612 lies on BQ, if we fit in the value of x equals 6 and y equals 12 into this equation for BQ on the left hand side, we should come up with the answer 72. So 5 times 12 plus 2 times 6 is equal to 60 plus 12, which does give 72. And since this is equal to 72, this verifies that T lies on the line BQ. Part C, we're asked to find the ratio in which T divides BQ. Looking at the x coordinates of B, T and Q, you see that B's x coordinate is minus 4, and we have to jump up 10 to get to the x coordinate of T. And then going from the x coordinate of T to the x coordinate of Q, we have to do a jump of 5. So the ratio in which T divides PQ is 10 to 5. But we can divide this down by dividing by 5 to a ratio of 2 to 1. To show that x minus 1 is a factor, we do synthetic division by 1. So our coefficients of the polynomial are 2, 1, negative 8 and 5. So dividing by 1, we first of all bring down the 2. 1 times 2 is 2, 1 plus 2 is 3, 1 times 3 is 3, minus 8 plus 3 is minus 5, 1 times minus 5 is minus 5, 5 plus minus 5 is 0. So we underline this, and this, because this is 0, that tells us that x minus 1 is a factor. We're then asked to factorise f of x fully. We've already pulled out the factor x minus 1. These numbers here give us the quotient. We started off with polynomial in x cubed. Once we divide by x minus 1, we then the polynomial in x squared. So these numbers stand for 2x squared plus 3x minus 5. If we now try and factorise the quadratic, to get 2x squared it must be 2x in one bracket and x in the other bracket. To get the answer minus 5, it must be 5 times minus 1 or 1 times minus 5. Because this is a plus 3x, it's going to be a positive 5. So if we put the 5 there and the minus 1 in the second bracket, that would multiply out to give 5x minus 2x is plus 3x. So that's us fully factorised. For part B, we're asked to solve the polynomial equation 2x cubed plus x squared minus 8x plus 5 equals 0. Now we've already factorised this. X minus 1 times 2x plus 5 times x minus 1. Notice that we've got a repeated factor. Make this equal to 0, and this means that x minus 1 could equal 0. 2x plus 5 could equal 0. Or x minus 1 again would equal 0. We're then getting x equals 1 twice, a repeated factor. And 2x plus 5 equals 0 gives 2x equal to negative 5. X is equal to negative 5 over 2. So that's us solved the polynomial equation. For part C, we're told that the line y equals 2x minus 3 is a tangent to the curve with equation y equals 2x cubed plus x squared minus 6x plus 2. Now this means that if we take the two equations, y equals 2x minus 3 and y equals 2x cubed plus x squared minus 6x plus 2. If we solve them simultaneously and we use y equals y, we get 2x cubed plus x squared minus 6x plus 2 is equal to 2x minus 3. Now when we take these two over to the left hand side to leave us with a 0, the 2x becomes a minus 2x, giving us a minus 8x in this position, and the minus 3 becomes a plus 3, giving us a plus 5 in this position. So this is 2x cubed plus x squared minus 8x plus 5 is equal to 0. And we notice that this is just the same equation as we've got in part B. So we've already worked out that the solution to this is x is equal to 1 twice and x is equal to negative 5 over 2. And since we were told that the line was a tangent and we've got x is equal to 1 twice, we know that there are equal roots at this point. So we know that this value of x must represent where the tangent is. In other words, the x value of 1 is the x coordinate of the point G. To find the y coordinate, we could use either of the two equations. It's easier to use the straight line equation, so that's what we'll do. Y is equal to 2 times 1 minus 3. 2 times 1 minus 3 is negative 1. So G is the point 1. And for part D, we're told that the tangent meets the curve again at the point H. Write down the coordinates of H. Now we know that the other place where the line meets the curve is where x is equal to negative 5 over 2. So the x coordinate of H is negative 5 over 2. What we then need to do is to work out the y coordinate of H. But what we could do is we could fit this value of x into the equation of the line. Y is equal to 2x minus 3. So y is equal to 2 times negative 5 over 2 minus 3. 2 times negative 5 over 2 is negative 5 minus 3 gives us minus 8. So h is the point, negative 5 over 2, negative 8. We've got the line with equation 3x minus 2y is equal to 0. We're asked to show that tan A is 3 over 2. Now tan A is also the gradient of the line. So tan of A is equal to m. So if we can work out the gradient of the line OA, then that will tell us what tan A is. Now the line is 3x minus 2y equals 0. Now in order for us to say what the gradient is, we'll need to rearrange this to look like y equals mx plus c. The first thing we could do is we could write that 3x is equal to 2y, taking the minus 2y over. Turning it round, we see that 2y is equal to 3x. But we need to have y equals, so we'll divide each side by 2. And that tells us that y is equal to 3 over 2 times x. Now since the line is crossing the origin, we've got a plus 0 at the end, but the value of m, the gradient of this line, is given by 3 over 2. So m is equal to 3 over 2, and m is also the tangent of the angle A. So that's us showing that tan A must be 3 over 2. We're now asked to find the value for sin A. Now sin A is defined in a right angled triangle as the opposite over the hypotenuse. In this triangle we could mark this side as 3 and this side as 2, since we know that tan A is 3 over 2. What we'll then need to do is work out the length of the hypotenuse using Pythagoras. So if we were calling that v, then v squared would be equal to 2 squared plus 3 squared. V squared would be equal to 4 plus 9. So v would be equal to the square root of 13. Which means that sin A is then the opposite over the hypotenuse, so that's 3 divided by root 13. For part B, the first thing we could do is we could rearrange this and work out what the tan of B is, because the tan of B is also given by the gradient of this line. So 3x minus 4y equals 0 means that 3x equals 4y. 4y equals 3x, so that y is equal to, divide each side by 4, 3 quarters x. Y equals 3 quarters x, so the gradient of the line OB is 3 quarters, and that is also the tan of the angle B. We can then mark in the sides. Opposites 3, adjacents 4, and we'll recognise this as a 3, 4, 5 triangle. Which means that the sine of B is the opposite over the hypotenuse, which is 3 over 5, and the cos of B will be the adjacent of the hypotenuse, which is 4 over 5. To find the value of sine of A minus B in part C, we look at our formula sheet and we see the expansion for sine of A minus B is sine A cos B minus cos A sine B. Now we've just worked out what sine B and what cos B are, so we can fill them in. From part A we know that sine A is given by 3 over root 13. We'll also need to know what cos A is. So working out cos A from this triangle, cos A will be 2 over root 13. So we can then come back here and fill in each of these. Now sine A is 3 over root 13 times cos B, which is 4 over 5, minus cos A, which is 2 over root 13, times sine b, which is 3 over 5. 3 times 4 is 12 over 5 root 13. Minus 2 3s are 6 over 5 root 13. Subtracting the two fractions gives us 6 over 5 root 13. So this is the value of sine of a minus b. We're then asked to state the value of sine of b minus a. Now the fact that it says state means we should be able to write it down, so this should be fairly easy. If we spot that this is actually the negative of that first angle, sine of negative a minus b is exactly what we're being asked for. So sine of b minus a is the negative of sine of a minus b. Now the sine of a negative angle is negative the sine of the positive. So since we've already found sine a minus b is 6 over 5 root 13, we can then write down that sine of b minus a must be the negative of this, negative 6 over 5 root 13.